Let's describe this apparatus. This is a power supply. When I press this button, 100 amps of electric current will flow out this red terminal into the copper bar, down the copper bar, across this copper pipe, back to this copper bar, and into the power supply. What's interesting about this particular apparatus is the array of permanent magnets between the two copper conductors. They're all oriented in the same direction, either North Pole up or North Pole down. You know that there will be a force exerted on this conductor, this copper pipe, because it's in a uniform or essentially uniform magnetic field. You should be able to make a prediction as to whether these magnets are North Pole up or North Pole down based on what happens to this copper pipe. Let's pause for a moment and figure out the polarity of the magnets based on the direction that this copper pipe will roll. Okay, that's enough. By now, you should have figured out what will happen to the copper pipe based on a prediction of North Pole up or North Pole down. So let's turn on the power supply and watch what happens. So you see that the copper pipe was accelerated towards you, and that should tell you something about the permanent magnets. I'm not going to tell you the direction quite yet. We're going to do this a few more times. So since we know the pipe will be accelerated towards you, we'll start with the pipe further back this time. Power supply on and off. Now, what will happen to the power supply, to the pipe, if I switch the direction of the current? We'll start down here, turn on the power supply. Let's try that again. Excellent. Let's see if we were right. Here is a compass. And if I bring this array of magnets up, you see that the red is pointing towards you, which means that these magnets are arranged so that North Pole is pointing that way. Remember, the red end of the compass points in the direction of the magnetic field. So the field for this points out and makes big loops around and back to the back side of this plate.